Okay, class, welcome to your next math lesson. We are still in Module 1. Today we are doing Lesson 5. This is about negative exponents. We've been talking about exponent rules for about a week now. And so far, all of the examples we've done, all the work we've done has been with positive exponents. Today we're going to see in last lesson was zero exponent. Now we need to see about exponents less than zero. So let's review the rules so far so that we have a reference and we have a list. Hopefully you have these somewhat memorized by now. Another reason we write them down at the beginning of every notes is so that it helps you memorize them. So I hope you're writing your notes down with me. The first thing we talked about was exponential notation, which is like x to the n, where x gets multiplied by itself, not multiplied by n. The n is how many times? X is multiplied by itself n times. Next rule we came up with was when we have the same base with two different exponents multiplied, we can just add the exponents. X to the m times x to the n equals x to the m plus n. Rule 3, when we have the same base with different exponents dividing like that, instead of adding the exponents, we subtract the exponents. And then when we talk about exponents with parentheses, we saw that when we have x to the m as a base with an n outside the parentheses, when it looks like this, we can multiply the exponents. Also with parentheses, we saw that when you have x over y, everything raised to the m power, the exponent gets passed to the numerator and to the denominator. Finally, yesterday in the last lesson, we saw that any base raised to the 0 power is always 1. Those are the 6 rules so far. We've talked about this with positive exponents. We talked about this with a 0 exponent. But what if the exponent is negative? What if the exponent is negative? When our 0 rule won't help us. Well, let's try this. Let's use a negative exponent in one of these rules to see what happens. Specifically, I want to use the first kind of rule we learned, multiplying bases. And so what I'm going to do is I'm going to put an exponent with a negative exponent in that rule just to see what happens, kind of like a little experiment. So let's use, just to see what happens, let's do 3 to the 5th times 3 to the negative 5th. Now you can see the bases are the same and we're multiplying, so we can use our rule. You know that what happens is we add the bases together. So we do 3 to the 5th plus 5 plus negative 5. Now you know that 3 to the 5th, well, you know 5 plus a negative 5. 5 minus 5 makes it 0. So this means the answer to this is 1. So now we need to consider how did 3 to the 5th become a 1? So somehow 3 to the negative 5th turned this into 1. Well, what you should think about, you should remember, perhaps you've heard something before in a previous year, something called a reciprocal. Especially when you were doing multiplying and dividing fractions. How does 3 to the fifth turn into 1? So what happens what else can we do to make that a 1? How does this turn into 1? Well, the easiest way to make a 1, and it might be easier if you think about how do we turn a 2 into a 1? How do we turn a 17 into a 1? How does anything get turned into a 1? What is a rule that we can use to turn it into a 1? Now, it has to be kind of the same rule. You cannot just say, just do -1, just do -16. We need a rule that follows the same pattern for all of them. So some of you might know this. You divide by 3 to the fifths. 3 to the fifths divided by 3 to the fifths equals 1. 2 divided by 2 makes 1. 17 divided by 17 makes 1. You divide by itself, which means, let's look at this. 3 to the fifth times 3 to the negative fifth equals 1. And 3/5 divided by 3/5 equals 1. So somehow, 3 to the negative fifth is multiplying by 3 to the negative fifth is the same as dividing by 3 to the fifth. So this is where that term called the reciprocal comes in. A dividing by 3 to the fifth is the same as multiplying by the reciprocal. So what we have to do, we take 3 to the fifth, dividing by 3 to the fifth is the same as multiplying by the reciprocal. So these are reciprocals. This equals 1. So which means if this equals 1, and this equals 1, and this equals 1, that means 3 to the negative fifth equals 1 over 3 to the fifth. That is what happens when you have a negative exponent. So both ways, we know following this rule, we get 1. If I say 3 to the negative fifth equals 1 over 3 to the fifth, then I do 3 to the fifth times 3 to the negative fifth. I said I can write this instead. Times 1 over 3 to the fifth. Turn that into a fraction also. I get 3 to the fifth divided by 3 to the fifth, which equals 1. So might be a little bit tricky, but the negative exponent just means it's a reciprocal. The negative exponent means it's the reciprocal. So negative exponent means it is the reciprocal. In other words, you have to move it to the other part of the fraction. The rule is actually this. The rule we're going to know after today, when you have a base and the exponent is negative, you just put it in the denominator and the exponent turns positive. That is the rule. A little bit tricky, a little bit tough with that one, but don't worry, I have another way to prove it. Another way to prove that this works. Let me show you. You'll recognize it a little bit from what we did yesterday with the 0 exponent. So let's prove it another way. In yesterday's video, you saw me make a chart that looked like this. To the fifth, 2 to the fourth, 2 to the third, 2 squared, to the first. And yesterday I showed you how we use this chart to find 2 to the 0 power, because 2 to the fifth is 2 times 2 times 2 times 2 times 2, which makes 32. 2 to the fourth is 2 times 2 times 2 times 2 for 16. 2 to the third is 2 times 2 times 2 to make 8. 2 squared is 2 times 2 to make 4. 2 to the first is just 2. And if you remember yesterday, I asked you to follow the pattern. So going down the chart, what is happening to the exponent? The exponent is doing a -1. And going down on this side of the chart, what is happening to the product? Where you can see the product is being divided by 2. It is all, but the reason it's divided by 2 is because that is the base. So we say the rule is divide by 2 or divide by the base. See, 32 divided by the base is 16. 16 divided by the base is 8. 8 divided by the base is 4. 4 divided by the base is 2. And yesterday I showed you that you keep going. 2 divided by 2 makes a 1. That's why anything to the 0 power is 1, because we just keep dividing by the bases. This is the pattern we saw yesterday in the video. You are familiar with it. But let's keep following the pattern. And we'll just keep following the rule, exponent -1. So now we get 0 minus 1 is -1. Let's do -1 minus 1 is -2. And -2 minus 1 is -3. We're going to keep the pattern going so that you can see what happens on this side of the equation. So remember, we're doing -1. We did that side. Let's keep the pattern going on this side, dividing by the base. So for this one, we need the 1, and the rule is divide by 2. 1 divided by 2 is 1/2. And we do it again. That's what happens when we divide by 2. What happens when we do 1/2 divided by 2? Well, 1/2 divided by 2. Remember your rules for dividing fractions. 1/2 divided by 2 is the same as 1/2 times 1/2, which is, we multiply straight across. 1 times 1 is 1. 2 times 2 is 2 squared. So now on this side we get 1 over 2 squared, which looks like this over here. Let's show you again. Remember, we're following the pattern. Divide by the base, divide by 2. So now we have to do 1 over 2 squared, divide by 2. Remember, dividing by 2 is the same as multiplying by 1/2. And this time we go straight across. We get 2 squared times 2 to the first, which means for the 2 to the -3rd turns into 1 over 2 to the 3rd. Do you see the connection? We are just following the same pattern. It works all the way down. This is why when we have a base with a negative exponent, like 2 to the -3rd, all we do is we just write it as a reciprocal. In fact, negative and exponent means the reciprocal. We just put the exponent positive, but we put everything in the denominator. A negative exponent means it has to be positive in the denominator. Now the opposite also works. Because what happens if you have a negative exponent that is already in the denominator? Just it has to be positive in the numerator. So a negative exponent means it has to switch to the other part of the fraction. So if the negative is here, it turns positive in the denominator. If the negative is in the denominator, it's positive in the numerator. This is the rule for today. Now let's practice some of these skills, starting in your book. Keep your notes in front of you just in case you need them. Book on page 43. And look, they give you the rules right there. They give you the rules again. Aren't they nice? Exercise 1, I do not feel like doing today, so you may cross off exercise 1. Exercise 2, we need to find the value of 3 times 10 to the negative second power. So we have 3 times 10 to the negative second. Using the rule we learned today, we know that the 3 can stay, but the 10 to the negative second, that's a negative exponent. So move it to the denominator and make it positive. Now this is multiplying by a fraction, so make them both into fractions. Just put a 1 underneath the 3. Does not change anything, but now we can multiply it straight across. 3 times 1 is 3. 1 times 10 squared is 10 squared. Now it says it wants the value, so we do have to keep going. 10 squared is 10 times 10. So this is actually 3 hundredths. 3 over 100. You can write it like a fraction, or it's also important to know how to turn into a decimal, because 3 hundredths also is 3 in the hundredths place of the decimal. So both of these answers are correct. It's 3 hundredths or 3 hundredths. Fraction style or decimal style. Exercise 3 is asking you to do the same thing. So try exercise 3 on your own a little bit. See if you can convert that into a fraction form or a decimal form. It is currently in exponent form. Pause your video and try to change it for us. So you pause the video, tried it yourself. We have 3 times 10 to the negative fifth, which the 3 can stay, but the 10 to the negative fifth has to move into the denominator, so it's positive. Remember, I make the 3 into a fraction to make the multiplication easier. Multiply straight across, 3 over 10 to the fifth. Now, 3 over 10 to the fifth is 3 in the numerator and 5 tens in the denominator, which is 3 over 100,000. So it's 300 thousandths. Or you can write it like that, because that is 300 thousandths and that is 3 in the 100 thousandths place. Tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. So both of those answers are correct. Knowing how to write it in decimal form is especially going to help you with exercise 4 when we want to write a decimal form into exponential form. We did this before with whole numbers. Now we're going to do it with parts of wholes, decimals. So we have 4.728, 4 and 728 thousandths. Let's start by separating this out just like we did the other day. This is 4 plus 0.7 plus 2 hundredths, 0.02, plus 8 thousandths, which is 0.008. Now this is where knowing your place value is super handy. So let's stretch this out into multiplication with place values. 4 is in the ones place, so that's just 4 times 1. 7 is in the tenths place, so that is 7 times 1/10. 2 is in the hundredths place, so that is 2 times 1/100th. plus 8 in the thousandths place, which is 8 times 1,000. Now that is expanded notation in fraction form, but we wanted exponential form. So what you need to do, 4 times 1, well, what is 1 as an exponent? 1 as an exponent, remember we work in base of 10. 4 times 10 to the 0. 10 to the 0 is 1. Now this is 7 times 10 to the negative 1, because there's 1 10 in the denominator. This, the 2, is multiplied by 10 to the negative 2, because 100 is 10 times 10, so there's 2 10s in this denominator, but it's negative because it's in the denominator. This last one is 8 times 10 to the negative 3, because 1,000 is 10 times 10 times 10. 3 10s, but it's in the denominator, so we put it negative. So that is expanded exponential notation. A little bit tricky. It does take some practice. Thank you for following along with it. For exercise 5, 6, 7, 8, 9, and 10, let's see. Let's do exercise 5 first. Okay, negative exponent, which means, following our rule, we move the base and the exponent to the denominator. 1 over 5 to the third. It means exactly the same thing. The only difference is this is the way the exponent is positive. Now, exercise 6, you have to work backwards a little bit. 1 over 8 to the 9th. Well, another way to write this is 8 to the negative 9. Because 8 to the 9th is in the denominator, which means the reciprocal is negative 8 to the negative 9 in the numerator by itself. Now for exercise 7, what you're going to do is you're going to do both parts separately. So the 3 does not need to change. That can stay like that. The 2 to the negative 4th can be written like this. Move it to the denominator. And the exponent goes positive. Now we just multiply. Remember, 3 you can turn into a fraction if that makes it easier for you. And then you can just go straight across. 3 times 1 is 3. 1 times 2 to the 4th is 2 to the 4th. So that's what it looks like with positive exponents only. Try to do 8, 9, and 10. Pause the video, try them yourself, and then come back. Okay, hopefully you saw with 8, 9, and 10, they are super similar to 5, 6, and 7. X to the negative third turns into 1 over x to the third. 1 over x to the 9th turns into x to the negative 9th, because it's in the denominator. When we move it to the numerator, the exponent turns negative. And this, remember, do separately. The x does not need to change, but the y turns into a fraction with a positive exponent in the denominator. You can turn x into a fraction to make the multiplication easier. Just put on top of 1. And you get x in the numerator, y to the 4th in the denominator. We're going to be playing with this quite a bit. Hopefully you are getting it. On your next page, they give you some more rules again, just to be a little bit helpful. Let's look at exercise 11 and 12, because those are asking you to use the rules we learned in other lessons combined with the rules we learned in this lesson. So you know that when we are dividing the same base, we can just subtract the exponents. So this is 19 is the base. We do 2 minus 5. The numerator exponent always goes first. But 2 minus 5 is going to be a negative number. 2 minus 5 is actually negative 3. But that's okay. We know how to make the exponent positive. We use the rule from today where it just goes into the denominator, and now it is positive. We write the reciprocal, just like that. Try number 12 on your own. Pause the video, see if you can figure it out. Coming back, what you should have done is you should have said, okay, it's dividing, same base, so I just subtract the exponents. Now the trick was, this is doing a minus a negative 3. Hopefully you remember from other years that minus and negative means to add. Both the minus and the minus turn into a positive. And so we have 16, we don't have 16 minus minus 3, we have 16 plus 3, so we get 17 to the 19th power. And that's our answer. That's another way to write this. This turns into this. Exercise 13, it's asking, we'll skip exercises 13 and 14. Don't worry about those. Just keep practicing the exponents like this. Let's go to the next page, page 47, and you're going to like page 47. It's an equation reference sheet. Keep this somewhere. Rip it out. Keep it next to you when we do all the work with exponents. You can keep it in a folder, in a binder, in a notebook, somewhere, because this shows you the rules for exponents that we've learned so far this year. It's a very good reference sheet, so you don't have to write them down all the time. Here is the exit ticket. What I would like you to do is I'd like you to try the exit ticket on your own right now. Pause the video, work on all 5 questions on the exit ticket, then come back with me when you're done and see how well you did. Okay, hopefully you finished all 5 on the exit ticket. Now let's see how well you did. This one, the base is 76,543. The exponent is negative 4. That's a negative exponent, so that we know from today's rule that means it's the reciprocal. So I can just put everything under a 1 and the exponent turns positive, just like that. That's it. That's the answer. You're done. You did not need to solve it. It just wanted you to write an equivalent expression. Number 2, f to the negative 4th power is just 1 over f to the 4th power. That's it. The f and the base and the exponent move to the denominator, and the exponent becomes positive. The base and the exponent move to the denominator, and the exponent becomes positive. Number 3, only one of those numbers has a negative exponent, so we're only going to change this one. The 671 is going to stay the same, but this one, the base and the exponent move to the denominator, and the exponent turns positive. This moves to the denominator, and the exponent turns positive. Now you can still simplify it a little bit more. This is a fraction, so make the other one a fraction. Just put it over 1. Multiply straight across. And 28,796 to the 1st power is just 28,796. I don't even need to write the exponent because it's just a 1. That is the simplified form. Now, number 4 and 5 are a little bit trickier because they ask you to use variables. But remember, a does not have an exponent, so a can just stay the same. B is the one that moves to the denominator, and the exponent turns positive. Nothing happens to a. Just make a fraction so that it's easier to multiply straight across. A times 1 is a. 1 times b to the 1st is b to the 1st. And b to the 1st is just the same as b. That is the final answer. Simplified form, no negative exponents. Now number 5, wait a second, the exponent is negative, but it's already in the denominator. What do we do in this case? Well, remember, it's written in your notes. Just make it positive and move it to the other part. Move it to the numerator. So this just turns into g to the first, which is just g. The exponent moves positive, and you move it to the other part of the fraction. It is going to take some practice. So make sure you look at your homework helper. Your homework helper has some more examples you can use that will help you. And there is the problem set. The problem set, I'm actually only going to ask you to do number 1 on the problem set. You can cross out 2, 3, and 4. This is, well, number 1 looks kind of complicated. It's much simpler than it is. I'm going to do number 1 for you. And then I'm going to do the first part. Let's say 1A, 1B, 1C. I will just do part A for you, and then you're going to do part B and C all by yourself. So let's look at 1A. 1A is 3 to the third times 3 squared times 3 to the first times 3 to the 0th times 3 to the negative first times 3 to the negative second. Now, what I'm going to do to make this easier on myself is I'm going to use the commutative property. Commutative, remember, if everything is multiplication, I can move things around. So what I'm going to do is I'm going to put the 3 to the negative second next to the 3 to the second. And I'm going to put the 3 to the negative first next to 3 to the first. Now I'm going to use something called the associative property, because the associative property, when everything has to be multiplication, you use the associative property. But it lets me make groups to decide what I want to do first, and I want to do those two first. I'm going to save 3 to the third and 3 to the 0 to last. Now for this one, 3 to the second times 3 to the negative second, you should remember your rules from lesson 2, where we just add the exponents. 3 to the second, 3 to the 2 plus negative 2. Same thing works for 3 to the first times 3 to the negative first. We just add the exponents. I did the parentheses first. So remember, I'm saving these for last. What is 3 to the 2 plus negative 2? Well, 2 plus negative 2 is 0. And 3 to the 1 plus negative 1. 1 plus negative 1 is also 0. Well, what is 3 to the 0? Well, in the last lesson we learned anything to the 0 is 1. So that's a 1, that's a 1, and that's a 1. So this is just 3 to the third times 1 times 1 times 1, which is just 3 to the third. 3 to the third is 3 times 3 times 3, which is 27, which is the answer to part A. So 1A equals 27. I would like you to try to do the same thing by using your positive and negative exponents to simplify this to make it super easy to solve. This is all mental math if you use your exponent rules. Just as a challenge, I'm going to have you do it yourself, but I will tell you the answers. If you do 1B correctly, you should get 25. And if you do 1C correctly, you should get 1. If you get those answers right, you are doing very well. If you don't, you might need to ask for help. Now, I know this was complicated work today. The negative exponents can be tricky. So just to help you out, there are several lessons on Khan Academy that will give you extra practice with negative exponents. Please use Khan Academy. Use the extra practice so that you can get really good at this. Use the extra practice time, please. Look on Khan Academy. Look on MobiMax. Use your resources. and I'll see you tomorrow for our next lesson.